Hello, my name is Heather Lee, and I am in the Texas Tech Fall 2021 Anatomy and Functions of the Visual System in Dr. Whitman's class, and I am going to show you a video of the eye model and how the functions work. I'm a very hands-on and visual person, so I was able to go onto Amazon and find an eye model for $27, so I'm very grateful for this learning tool. It's been very helpful. So let's get started. Let me focus the camera down on the model so you can see it better. Okay, so if we're looking at the eye model, this clear covering right here on the front, this is a cornea and is a transparent protective layer. Blood vessels are not found in here. The nourishment and the oxygen is received through the aqueous fluid and the tears. The conjunctiva is a clear membrane that covers the sclera and it lines the inside of our eyelids. Now the white part that you see all around the eye is called the sclera. So literally when someone says, "Show me the whites of your eye," they are referring to this right here, the sclera. It is a tough, white, fibrous outer layer, and it is a very protective layer for the eye itself. Okay, so let's move on to the extrinsic muscles around the eye. On the eye model, I'll show you 1, 2, 3, and 4 muscles of the eye. So let's start here on the top. So say for example that I want to look up at the stars or roll my eyes upward. The muscle that I'm using on the top is called the superior rectus muscle. Moving down to the bottom part, if I want to look in a downward motion, maybe to tie my shoes or to read a book, I'm going to be using the inferior rectus muscle. Okay, moving on to the side here. This muscle right here is the medial rectus muscle, and this is the one that rolls closest to your nose. On the opposite side is the lateral rectus muscle, and this literally rolls laterally towards the ear per se. Okay, so when I talk about the eye, there's two segments. There is the anterior portion of the eye, which is the front portion of the eye, and then the back portion of the eye is the posterior segment. Okay, so let's look inside the model and let's look at the layers. So hopefully you can see the colors on this pretty well. But it has 3 layers, so let's start at the top. Of course, the white one we have already talked about. That's the sclera. That is the first layer, and that's the tough white fibrous protective covering right here. The second layer down is the second color you see, and that's a choroid. That is underneath the sclera, and this is where the blood vessels provide the nourishment to the retina. Okay, and then this bottom third layer is the retina itself. This is the inner lining of the back chamber of the eye, which contains the photoreceptors and is composed of cones and rods. So the cones provide the detailed vision and the colored vision, and then the rods provide the night vision and the global movement. So rods and cones receive the light rays that enter through the pupil, and it converts these light rays into the electrical impulses which are relayed to the brain via the optic nerve. Okay, and the oral serrata, that is where the retina ends and the choroid layer can be seen. Okay, so let's look over here on the eye model itself. This very large bubble-looking thing is called the vitreous humor. And this makes up 2/3 of our eye and is a clear-like jelly substance, and it fills the posterior part of our eye. And it's easier to show you on this model right here. This little section right here is going to go around in a circle around the pupil. This is called the ciliary body, and it is attached to the iris. And these muscles control the accommodation of the eye. Another word for accommodation is focus. And the function is to change the shape of the lens. So let me find the lens right here. So let's place the lens right there next to the ciliary body. Okay, so let me show you how this works. So if I want to look at an object close up, the ciliary body is going to contract very small and thinned because the light bends more to see the object. So this little lens right here is going to get bigger so we can see objects up close. If I want to look at an object far away, this ciliary body right here is going to relax and the lens is going to become thinner so we can see the object far away. Isn't that interesting? So moving on to the lens itself that we just talked about, this is a transparent structure of the eye that focuses light by changing the curvature, thin to thick. So if you watch Dr. Harting's video, he talked about as we age, the lens gets more brittle and less elastic. So when it contracts, it doesn't rise up as much, so the way it used to. So when you get older, like myself, you have a tougher time seeing things up close, like reading a book. Like I myself noticed this change in my 20s and 30s. I had great vision. And then when I got to my 40s, I noticed that I had a harder time reading material and books. And so I had to go get some dollar store readers. I'm sorry, Dr. Whitman, I know I shouldn't have gone to the dollar store, but they were helpful at the time. And I could read, and I just progressively got higher and higher in my level of reading classes. And once I hit my 50s, I had to go to an optometrist and get some bifocals. So I'm very thankful because I wouldn't be able to read a thing without them. Okay, so moving on to the suspensory ligaments. These are the long, thin fibers which connect the lens to the ring of the ciliary body muscles. Okay, so let's go back over here to this model. Okay, so we talked about the cornea. This is the protective layer that layers the eye, and its curvature here provides the focal strength of the eye. It's the only transparent tissue in the body. Okay, aqueous humor. Aqueous humor is a watery fluid that is found in the anterior chamber of the eye, and it provides some of the nutrition for the surrounding parts of the eye. Okay, so right here you see these dots here and here at the top and the bottom. This is called the canal of Schlemm. This is where the aqueous fluid is removed into the corners. Those corners are the canal of Schlemm. So if the canal is blocked, you can have glaucoma. So if it can't be released, it creates an internal pressure on the inside of the ball of the eye, and the pressure affects the optic nerves back here, and it causes damage and it causes blindness. Okay, so moving on to the iris. The iris is the color of your eye, and those colors are brown, green, blue, and hazel. I have hazel eyes. My daughter has the most beautiful ocean blue eyes. They're gorgeous. So this controls the amount of light entering the eye by enlarging or minimizing the size of the pupil. Now the very cool thing about the pupil, this is the round hole in the center of the iris where light passes. This little pupil is an actual hole. There's nothing there. You can't even touch it. So this is the door to which the light enters. I just found that fascinating that there's absolutely nothing there. I always thought it was a black dot. And then of course we already talked about the lens. So moving on to the posterior segment of the eye. If I hold this up right here and I find this little dot in the back, can y'all see that? That is the macula. That is the center of vision. This is a small thinned out area of the retina consisting of exclusive cone photoreceptor cells, and they provide high visual acuity. Now in the center of that macula is the fovea centralis, and this is the only place that we have 20/20 vision. It has the highest concentration of cones. Moving on back towards the back. Oh, also, while I'm on the cones, cones detect the color of light, colors red, blue, and green. The most common type of color blindness is the red and green color. And the reason that is because they're missing the red and the green cones. My husband is colorblind to the color red, so he has a very hard time distinguishing when he is wearing red or orange. So now I know why. Okay, moving on to the very last thing we're going to talk about. This right here is the optic nerve. This is a bundle of fibers carrying vision-related impulses from the retina to the brain to create the image that we see. And right here at the beginning of the optic nerve is the optic disc. This is the head of the optic nerve. And this is the area on the retina where the optic nerve leaves the eye, and this leaves a blind spot on each eye. I hope that you've learned a lot about the eye using the eye model. Y'all have a blessed day. Thank you.